Hi guys, in this video we are going to be talking about finding percentiles and quartiles. So let's start off by talking kind of remembering what percentiles were. Remember that this is the percent of individuals that score at or below a specific score. So what we're going to be doing is we're going to find z-scores associated with percentile. So this is a little bit confusing. We're still going to be using our unit normal table. So I've got an example on how to do this to help you guys out. So we're going to determine this percentile that would fall below or above the mean. So remember that the percentiles that are less than 50% would be below the mean. And in that case, we are going to use column C to find those values. Any percentile greater than 50%, we would be using column B to find those percentiles. And we always want to find the value in the appropriate column closest to your percentile. So sometimes you'll get one that it's right on, you'll be able to like, yep, there it is. I don't have to worry about it, like 90%, it might just be in there and that's it. But if it's not, then you find the one that is closest to whatever percentile they've given you. And then we're going to determine the z-score associated with it. Remember that if it was less than 50%, then our z-score is going to be negative because it's falling to the left of our mean, and anything to the left of the mean is always negative. All right, so here's an example. We want to find the z-score associated with the 40th percentile. So since the 40th percentile is less than 50, we're going to be looking in column C of our unit table, and we're going to try to find the value closest to 0.000. So just think about making the 40th percentile a decimal. So you're moving the decimal forward 2 spots. And then the only reason we added the extra zeros is because if you'll notice our chart is always in 4 decimals. So it just makes it easier to add those extra zeros onto the end. So if we go looking in column C, that's this guy right here. And we're going to look for the closest numbers to 0.4000, and you'll notice that it's not actually on there, but these guys are the closest. We've got 0.4013 and 0.3974. So now we just have to determine which one of these is actually the closest, and the way that we're going to do that is we're just going to subtract them from the 0.4000. Now when I did my subtraction, you notice for the first one I put the 4.4013 first because it's larger than my 40th percentile. It doesn't really matter what order. You're not really concerned about the sign of these guys. You're just concerned about which one actually is closer. So we get 0.013 here for this guy. And then when we do the same thing for the 0.3974, we get 0.026. Notice that this number here is smaller than this number here. So that means that we're going to use the 0.4013 as our value that we're going to get because it's the closest to the 40th percentile. So that means we're going to come over from that value over here to column A, and we're going to say, well, our z-score is going to be this 0.25. But remember, this is a 40th percentile, so it is lower than 50%. So it's actually going to be the negative of that. So our percentile that we want, or our z-score that we want associated with the 40th percentile is z equals negative 0.25. Now you might be saying, why did we go through all of this process to figure out the z-score? Because what we're going to be doing in the next example is I'm going to give you the mean and the standard deviation, and I want to figure out what score is associated with a certain percentile. So we're going to do this for the IQ test. So IQ tests are a standardized test. On a normal distribution, it has a mean of 100 and a standard deviation of 15, and we want to find the score associated with the 90th percentile. So since the 90th percentile is a positive value, we are going to be looking in column B. Okay, so again, because it's above our 50%, it's going to be this column B, and we're going to be looking for the one that is closest to the 90th percentile. That happens to be this 0.8997. He is only 3/300ths of a thousandth points away. I know that there's a 0.9 9015, but that's too large. So our z-score that we're going to use is going to be this 1.28. Since we are at 90th percentile, it is going to be a positive value. So we find that our z-score associated with the 90th percentile is 1.28. So for step 2, we're going to use that z-score to find our x like we did in chapter 5. So that, remember, that was when we did our x is equal to our z-score times our standard deviation plus our mean. So in this case, we've got 1.28 times our 15 plus our 100. So we've got 19.2 plus 100. So a score of 119.2 on the IQ test is a score of the 90th percentile. That means that 90% of the people score below 119.2. Okay, so then we can also use z-scores to help us find quartiles if we know the mean and the standard deviation. Our quartiles have specific values that they are associated with on our curve. So each quartile is associated with a z-score. So Q1, remember Q1 is the 25%, so that's associated with the score of z equal to negative 0.67. The Q2, that's our median, or our center of our data, and since we're talking about a normal curve, that's going to be our median, our mean. So that's z equals 0. 50% of our data lies to the lies below, 50% of our data lies above it. And then the last one, Q3, that's our 75% quartile. That's going to be 0.67. That's going to be on our positive side. And remember, these quartiles just split our data into 4 equal areas. So then, if we want to find the quartiles for the IQ test, where we know that the mean is 100 and the standard deviation is 15, we're just going to do the exact same thing we did on the previous problem. So for Q1, it would be negative 0.67 times 15 plus 100. So we would get negative 10.05 plus 100. So 89.95 is the first quartile for the IQ test. Q2 actually always is going to end up coming out to be the mean. Again, remember, when we're talking about a normal distribution, the mean and the median should be the same value. So 0 times 15 is going to give me 0. 0 plus 100 gives me 100. So my Q2 is just going to end up being my mean of my data. And my Q1 is going to be the positive 0.67 times 15 plus 100, which would give us 110.05. So now we have our quartiles based off of the mean and the standard deviation and using our z-scores. And again, remember that these values here for Q1, Q2, and Q3 will never change off of these z-scores. So this might be something you want to have written down somewhere so you don't have to look it up every time. And now once we have our quartiles, we can also find our interquartile range. Remember, our interquartile range is just Q3 minus Q1. Oops, I did see an error right there. That should be a Q3, by the way. Okay, so our Q3 for our example was 110.95 minus our Q1, which was 89.95, which gives us an interquartile range of 20.1. If you have any questions about how to find percentiles or how to calculate scores based off of percentiles and the z-scores, just send me an email, let me know.